How can an equation be used to represent a situation? Here we have the situation. Together, April and Kelly have $42.03. If April has $13.79, how much money does Kelly have? How do we write an equation and solve this problem? In this lesson, you will learn how to write and solve an addition equation by using a bar model. A bar model can be used to show that two sides of the equation are equal. For example, here we have the equation 3 plus 4 equals 7. To create a bar model for this situation, I'd have an equal sized bar for each side of the equation. So if one side of my equation is 7, I would create a bar for 7. This is my total, my biggest bar. The other side of the equation is 3 plus 4. Together, 3 and 4 equals 7. So 3 and 4 together should equal the 7 bar. See how the bar model shows the relationship of the equation. The big bar shows the whole value, and the smaller two bars equal the whole. By looking at the bar model, we can see how the equation can be written in different ways. We could write 3 plus 4 equals 7 as 4 plus 3 equals 7, 7 minus 3 equals 4, and 7 minus 4 equals 3. These equations are all equal to each other, and they are called fact families. Fact families can be useful when solving equations. Here we're given the situation of Kelly and April. Together, they have $42.03, and April has $13.79. We want to know how much money Kelly has. So let's break down this problem by creating a bar model. First, we know together the girls have $42.03. This would be our first bar. Bar models do a great job of showing the relationship between a total and its parts. So if $42.03 is our total, what would be our parts? What April and Kelly have individually. So if April has $13.79, that would be a small bar, and we're left wondering how much money Kelly has. So our bar model shows that April's money plus Kelly's money equals $42.03. The bar model created for this situation will help us write an equation. Remember, an equation must have the same value on both sides of the equation. Using these equal sized bars will help. We can see that $13.79 and Kelly's money is the same value as $42.03. So we could write this as $13.79 plus Kelly's money equals $42.03. Would we leave an equation like this? No, we want to use a variable to represent our unknown value. I'll use K for Kelly's money. So now our equation would be $13.79 plus K equals $42.03. So we have a visual and a mathematical representation of our situation, but how much money does Kelly have, and how do we even go about solving this equation? By looking at our bar model, we can see that Kelly's money is what's left after April's $13.79. If we were to take away April's money, would we be left with Kelly's money? We would. Let's see how this looks in our equation. We know that we have to subtract April's $13.79. When working with an equation, we need to make sure that we treat both sides of the equation equally so that they stay balanced. We want to get rid of April's money on both sides. So we start with our first side and we subtract $13.79 and we're left with Kelly's money. Now we subtract from both sides, so we take $42.03 and we subtract $13.79 to leave us with $28.24. This is what Kelly's money should be. By subtracting both sides, we are performing the inverse operation because originally we were adding, so the inverse would be subtracting. Here we have the original situation, our equation we used to represent, and we've said that Kelly has $28.24. But does this make sense? We know that together April and Kelly's money should equal $42.03. So, does $13.79 plus $28.24, is this equal to $42.03? It is, so our answer would be correct. One misunderstanding that can be made from solving equations is not understanding why we must perform the inverse operation to both sides of the equation. We do it because of the property of equality. It says that whatever we do to one side of the equation, we must do to another. Let's see why. Here we have the equation 3 plus 5 equals 8. If we were to subtract 2 just from one side of this equation, we would get 3 plus 5 equals 6. Is this correct? It's not, so this would be untrue. But if we were to subtract 2 from both sides of the equation, I would get answers varying from 1 plus 5 equals 6, 3 plus 3 equals 6, and 6 equals 6, depending on where I subtracted that 2 from the one side of the equation. So when I subtract from both sides of the equation, it remains equal. So looking at our original equation, I know that I must subtract 1379 from both sides in order for the equation to remain equal. In this lesson, you have learned how to write and solve an addition equation by using a bar model.